Hi, I'm not here today, but we're still going to take notes. So find your homework packet. It says Informal Geometry, Unit 5, Triangles, and we're on Lesson 5.3. So this is towards the back of your packet. And go ahead and fill out all the information that you see on here. So the date, we've got 2 essential questions, the triangle inequality theorem, and example 1. So that's a lot to do. I need you to pause the video right now, get all of this down, and then once you're done, go ahead and press play again. So hopefully you have all this written at this point. I want to read through this. We talked about it really quickly at the end of class last time when we were doing all those toothpick things. But the triangle inequality theorem says, if you add the 2 smallest sides of a triangle together, the sum must be greater than the third side. And that's because otherwise the 2 smaller sides just won't be able to meet. And so this is example 1. We've got a triangle maybe with 3 sides, 4 centimeters, 3 centimeters, and 1 centimeter. And we need to know if that actually can make a triangle. So what we're going to do is write an inequality and see if it's true or not true. The theorem says if you add the 2 smallest sides of a triangle together. And so circle the smallest sides. It's that guy and that guy. And we need to add them together. That needs to be bigger than our third side. And so that's going to look like this. 1 plus 3, those are our smallest sides, must be greater than, that's our greater than symbol, our other side, which is 4. And then we just need to see if this is true or not. So we'll simplify. 1 plus 3 is 4. Drop that down, drop that down. This says 4 is greater than 4, but that is not true. 4 is equal to 4. It's not greater than 4. And so next to this, I want you to put an X and then say not a triangle. It's not a triangle because this inequality didn't work. Let's look at another example. Okay. So go ahead and write that one down. And then I want to know if I had, this says centimeters, but if I had 8 toothpicks on one side, 2 toothpicks on one side, and 7 on the other, would I be able to form it into a triangle? And it turns out with this one, it is possible. So let's think about why. I want you to circle the 2 smallest sides here. So that's those 2. And then we're going to write our inequality. We're going to add those together. 2 plus 8. 2 plus 7. And that must be greater than our third side, which is 8. And so if we simplify this, 2 plus 7 is 9. 9 is greater than 8. It works. And so this is a triangle because that inequality worked. Let's do one more like this. Copy that down. So same process. I'm going to wait a minute because I would like for you all to write the inequality and check to see if it works. So I'm going to give you about 30 seconds for that, and then once the 30 seconds is over, I'll go over it. Try it on your own. That was about 20 seconds, but that's probably enough. So we've got our 2 smallest sides. So I'm going to add them up. 4 plus 5. And that needs to be greater than my third side, which is 14. 4 plus 5 is 9. And this is not right. 9 is not greater than 14. 9 is less than 14. So because that didn't work, this is not a triangle. And it should be obvious. If we were to try to draw it and we had like 14 centimeters here and then 4 and 5, those wouldn't really even come close to touching to form a triangle. Okay. So that's the triangle inequality theorem. The other part of this lesson involves putting sides and angles in order from least to greatest. And there's really just one important thing that you need to know. It's a theorem, but I'm going to phrase it in hopefully sort of an easy way. Bigger sides of a triangle are across from bigger angles. Smaller sides of a triangle are across from smaller angles. So this is very simple. The sort of problem that you'll see is something like this. So example 4. We might have a triangle like this with, let's go A, B, C. Let's say this is 40 degrees, this is 30 degrees, and this is 110 degrees. So go ahead and fill all that out for me. Pause the video if you need more time. And then the problem would say something like list sides from least to greatest. So this is really simple because all we have to do is look for, least means smallest. So we're going to look for our smallest angle, which is 30 degrees. And we're going to look across from it. The smaller angle is going to be across from the smaller side. So that means the smallest side here is this side here, AB, because this side is across from the smallest angle. So for listing them from least to greatest, we would start with AB because that's the smallest angle. Then we would go to the next smallest angle, which would be 40 degrees, and we would look across the triangle. So away from the angle, across from the triangle. And the side across from my middle angle is this side here, BC. So that would come next. And then my biggest side is going to be across from the biggest angle. This is the biggest angle, and so when I look on the other side, that's talking about this side here, AC. So even though I don't know exactly the lengths of each side here, I know which is the smallest and which is the biggest, because the smallest is across from the smallest angle and the biggest is across from the biggest angle. Let's do another example. Guys, feel free to pause and rewatch sections of this if you need to, if I'm going too fast. Okay, so example 5, we're going to have another triangle. I'm going to make it look equilateral, but it's not going to be equilateral. And we'll do XYZ this time. So copy that down. And then what I want you to do is list the angles from least to greatest. So here, it's really the same thing, right? Bigger sides are across from bigger angles, smaller sides are across from smaller angles. So to find the smallest or least angle, we want to look for the smallest side. And so our smallest side, we have 3, 3.5, and 4. So this is our smallest side, and that is across from angle Z. If this is our smallest side, this is our smallest angle. So Z would come first, and we could say angle Z. My middle side is this. So if I want to know what the middle angle is, I sort of look across. X would come in the middle. So angle X is the middle-sized angle. And then the biggest angle would obviously be across from the biggest side, which would be angle Y. So I've just listed the angles from least to greatest. And then there's just one more type of example that I want to do with you. So we might have a situation, and we're going to try to make like a bow tie here, kind of thing. So draw that. Label all of that. Okay. So the question here is, what can we conclude? Are there any conclusions we can make about what sides might be bigger or smaller than other sides, or what angles might be bigger or smaller than other angles? So I'm going to look at side AC because it's across from an angle I know, and I'm going to look at side CD because that's across from an angle I know. And I want to be able to put an inequality symbol here, greater than or less than symbol, to show which side is going to be bigger. And even though, again, we don't know exactly what the side lengths are, we do know which one is bigger because bigger sides of a triangle are across from bigger angles. So our bigger angle here is this one, 100 degrees, and that's across from CD. That's going to be bigger than the side that's across from 95 degrees because the angle's bigger. So CD has to be the bigger side. And so I don't know if you learned this way back when you were learning inequalities, but if this side is the bigger side, which it is, then we want to orient our symbol like this. And the trick to remembering is that it's sort of like, this is like a little Pac-Man, and Pac-Man is always going to eat the thing that's bigger because it's hungry. So this means AC is less than CD. AC is less than CD because that angle is less than that angle. So this should be enough to get you through the rest of what you need to do today, sort of on your own. I would like you to take a minute and write a summary because I won't give you a stamp unless that summary is done, and then go ahead and write out key points or questions that you might have. So I'm going to do one quick example with you back on the toothpick triangles. So I have this from last class. We did kind of these first ones together, and then we did G on the back. So I think I want to do just a couple more with you. Maybe just one more, in fact. I think I want to do, let's do C together. So if you don't have toothpicks right now, that's okay. I'm going to grab them. You can just watch. We're doing C together. All right. It says AB is 2, BC is 1, and AC is 2. So what you're going to have to do here is create a triangle where you've got one side that's 2, another side that's 1, and then somehow another side that's 2, and you're going to have to connect it. Now, if you wanted to make sure it would work, we could use the triangle inequality theorem, right? If I take 2 of the smallest sides and add them up, it needs to be bigger than the third side, and that is going to work here, because if I take my 2 smaller sides, 1 and 2, and add them up, that's 3, which is bigger than my third side. So I know it's possible. And so then it's just a matter of making it work. So it's going to look something like this. So what I want us to do right now is sketch it, classify it by the sides and angles, and then order the angles from least to greatest. So it's okay if you didn't get to build it. We can draw it together. It looked kind of like this, where we had 2 triangles going one way. And I'm going to label that AB because it says AB is 2. I said triangles when I meant toothpicks. Okay, AB is 2. And then BC was 1, and so this has to be C right here with 1. And then AC was also 2. So you're just going to do kind of the best you can to sketch it, but it's going to look something like that. 2, 1, and 2, and you need to make sure that the side lengths are correct. So there it is. Remember that if it doesn't work, you need to show me an inequality like we did down here to show that the triangle won't work. Okay. All right, so there's the sketch. We're going to classify it by the sides. It's not equilateral because the sides are not all the same, but it is isosceles because 2 of my sides are the same. Acute, obtuse, or right. This is an acute angle. It's less than 90 degrees, and both of these are acute as well. I don't know what they are, but I can clearly see that they're less than 90 degrees. So this is an acute isosceles triangle. And now we're going to list the angles in order from least to greatest. So that's kind of what we just talked about. If I want to list the angles in order from least to greatest, I need to think about the sides in order from least to greatest. So that's my smallest side. That is across from angle A. So angle A is my smallest side. Now, you might be a little confused about the rest of it. Where do I go next? These two sides are the same length, and that means the two angles across from them are the same measure, which we already knew. We already knew that in an isosceles triangle we have two congruent sides and two congruent angles. So we can't really list the other two in order, so I'm going to kind of put them on top of each other. Angle B and angle C are the same. So this is the smallest, and then these are bigger, but they're congruent, so I'm kind of piling them on top of each other, if that makes sense. Okay. So here's what I'd like you to do for the rest of class today. I would like for you to start by finishing this toothpick activity, the front and the back. I would love for you to work together just because you learn more when you work together. I expect the whole thing to be filled out. On the back, there are right and wrong answers because I'm telling you exactly how to make the sides. Please don't forget to label your vertices so that you can do this last box. On the front, though, there are multiple ways to build these triangles. So there are wrong answers, but there are multiple right answers as well. When you're done with this worksheet, please put it in the inbox over on the side of the room, and then I need you to get to work on tonight's homework assignment, which is a little bit long, but I'm hoping you'll have time to finish it in class. The homework is pages 7 and 8. So page 7 looks like this. It's just a few problems, and then page 8 is over here. I do want to tell you that some of these are kind of tricky and you might have a little bit of trouble with them, but only a couple. Most of these are really within your ability to get done even without me here. So please do your best to get pages 7 and 8 done after you do the toothpick triangles and turn it in. At this point, all we have left in this unit is review and test, and that means this entire packet should be done by the next time that I see you, and it's really, really important that you do it because we don't have time to do all the work in here and review next class. We need to be able to just review. So when do I see you next? Tuesday. By Tuesday, please make sure this entire packet is done to the best of your ability, and that way we can just go over the ones that were really hard for you. Get to work.